The topic this afternoon is AR, VR, and Metaverse. Augmented reality, virtual reality, and Metaverse. At the beginning, I will request our chairman, West Bengal State Center, Dr. Nirmal Das, to give his welcome address. Over to Dr. Nirmal Das.
Well, a very, very good afternoon to you all. Dr. Hemant Thakre, President, Vice President, Engineer Sandeep Kumar, Vice President of Institution of Engineers, Dr. J. Ranganathan, Chairman, CATE of Institution of Engineers, Professor G.S. Mundadar, Chairman of Electronics and Telecommunication Division Board, Dr. Raju Boshak, Honorary Secretary of West Bengal State Center, Engineer Ramchandra Chakraborty, Joint Honorary Secretary of West Bengal State Center, Engineer Chanchal Chakraborty, Convener of the Division, and our panelists today, Mr. Peturaj, HAI Division, Reliance Jio, and Mr. Rahul Kumar, corporate members, distinguished guests, ladies and gentlemen. It is indeed my great pleasure and honor to be speaking here today in the webinar on AR, VR, and Metaverse, organized by the Electronics and Telecommunication Division of West Bengal State Center, the Institution of Engineers, India. Being the chairman of West Bengal State Center, IEI, it is my proud privilege to address the gathering of eminent engineers, technologists. On this occasion, let me extend a warm welcome to you all, and especially our panel speaker, corporate members, distinguished guests, staff of IEI, students, and other dignitaries. The metaverse is an essentially virtual environment where people can communicate with one another through a variety of technologies. Hardware and software are used in tandem to achieve this. Although each business has a different vision for this idea, they all envision a network of 3D world that are produced in real time and that many people can enter at once. In the metaverse, one can work, learn, chat, relax, go to the virtual contents, concert, and other activities. It is designed to be a simulation of the real world. However, the metaverse is maintaining an integrity in its market form. According to the Facebook, the metaverse should combine real world and virtual worlds, allowing for peer-to-peer lifelike interactions in virtual workplace. On the metaverse, one might theoretically engage in any activity, including traveling, playing, reality, and virtual reality are all strongly tied to the concept of metaverse, VR. With the use of augmented reality technology, one may incorporate virtual objects into the actual environment. The combined market for AR and VR is anticipated to be worth up to $300 billion by 2024 and and as estimated by Morgan Stanley according to Stansia. Although the concept of metaverse appearing intriguing, it is difficult to predict what the future may hold for it. The development of 5G and rising popularity of VR and AR technologies may truly help to provide the right conditions for something like this. The future of AR/VR business appears promising, given how strongly the metaverse relies on these technologies. Businesses that want to develop augmented reality applications and virtual reality features have a great opportunity of satisfying the market's expanding demand. VR/AR technology are essential to the creation of metaverse. The market is likely to expand rapidly in the years to come. Today, we hope the panelist speakers would cover all the possible aspects of VR/AR technologies and the metaverse concept. Let us educate ourselves and try to explore the insight of this. Thank you once again, and I hope you will get a lot of information through this webinar. Thank you once again.
Thank you, Mr. Chairman, for your beautiful welcome address. From the organizer side, I say a few words about our topic today, AR, VR, and Metaverse. Simply speaking, the much discussed Metaverse represents the next generation universe. The prime implementation infrastructure for Metaverse is the future Internet Wave 3.0, which leads to a kind of 3D virtual world wherein users interact with various spaces and virtual reality components using digital avatars. In a nutshell, the metaverse is the grandiose intersection and seamless crossover between the real and the digital world. The potential and promising digital technologies turn out to be an enabler of the metaverse. A dazzling array of pulsating metaverse applications are being envisaged and realized through the smart leverage of pioneering digital technologies and tools. The prominent metaverse technologies include artificial intelligence, machine and deep learning, algorithms, the Internet of Things, 5G communication, digital twins, digital spaces, virtual, augmented, and mixed realities. I don't see any VVIP is there participating, so I directly go to introduce our honorable panelists this afternoon. We have panelist Dr. Pethuru Raj. He is Chief Architect and Vice President at the Edge AI Division, Reliance Jio Platforms, Bangalore. And Dr. Raj has been working as the Chief Architect and Vice President at the Edge AI Division, Reliance Jio Platform, Bangalore. Previously, he worked in IBM Global Cloud Center of Excellence, Wipro Consulting Services, and Robert Bosch Corporate Research. In total, he has gained more than 22 years of information technology industry experience and 8 years of research experience. Finished the CHI-sponsored PhD degree at Anna University, Chennai, and continued with the UGC-sponsored postdoctoral fellowship in the Department of Computer Science and Automation, Indian Institute of Science, Bangalore. Thereafter, he was granted a couple of international research fellowships, JSPS and JST, to work as a research scientist for 3.5 years in 2 leading Japanese universities. He focuses on some of the emerging technologies, the Internet of Things, explainable, efficient, and edge AI, big and streaming analytics, blockchain, digital twins, and metaverse, cloud native, edge and serverless computing, reliability engineering, microservices architecture, and event-driven architecture, 5G and 6G communication standards. He has a lot of technology books and publication to his credit. We have a younger panelist, Mr. Rahul Kumar. He introduced himself as a network evangelist. He is a senior professional with diversified experience of over 17 years in the telecommunication and ITES industry, having extensive experience in delivering significant improvement in TCO and strategic digital transformation projects on various cutting-edge technology like cloud, IoT, SD-WAN, and 5G. Worked with leading global organizations, Colt, BT, Tata, Jio, and JT in the past in a leading role. As a moderator, we have our all familiar Chanchal Chakraborty. He is BE MBA, has more than 35 years of experience in telecom and IT, worked with flagship companies like CSC, NTBC, and Department of Telecom, BSNL, and worked as Chief Technology Officer and Vice President in Aircel, Uninor, and Reliance Jio. He had wide experience in planning, design, procurement, installation, and maintenance in all fields of telecom. Currently, He is the CEO of ATMI Private Limited. He participated in several national and international seminars, including GSM Congress at Cannes, France, and Berg for international roaming. He has received different accolades, including the Vishisht Sanchar Seva Award from the Ministry of Communication. Professionally associated with IEI India and ISA USA, a team player and loves to serve society to the best of his ability. Over to Chanchal to conduct the session this afternoon.
Thank you very much, Ramda. So today we'll start the most scintillating presentation on AR, VR, and Metaverse. So now I'll invite Mr. Petru Raj and Mr. Rahul Kumar to take over. Thanks a lot.
Yeah, I am Petru Raj. You want video or I can manage with audio only?
You can manage also with audio, absolutely don't have problem. But only thing is the presentation and other things should be visible, that's all, no problem.
Okay,
Already.
so I think I have already shared my presentation.
Yeah.
Is it, are you able to see my presentation?
Yes, yes.
Absolutely, yes,
Okay.
no issue,
Okay.
no issue.
Great, great. Yeah, I am Pedro Raj, working for Edgy AI Division, Reliance Geo Platforms Limited, Bangalore office. So at the outset, I extend my gratitude to all the distinguished members of this IAE for giving me an opportunity to give a presentation on Metaverse technologies. So I also thank Rahul Kumar also for introducing big people from IEE with me. So I'm thanking all the people who have participated in this session. I think this session will be useful and informative for you, all the people. Today we will focus on AR, augmented reality, virtual reality, VR, then about the Metaverse. Okay, so I was reading about an article. The term Metaverse came into being in the year 1992 itself. Now we are at least 30 years past. So it is not a new term. It has been there, but due to the lack of implementation technologies, enabling technologies and tools, that word Metaverse could not sign. Nowadays, we have so many powerful pioneering technologies that will help us to jump into the era of the Metaverse. So that's what we are going to talk. So I will introduce some of the technologies. Then I will hand it over to Mr. Rahul Kumar. He will throw some light on AR and VR. Then I will take over from Rahul Kumar towards the end of the session. Okay, that is the arrangement that we have made. So, yeah. Today, every industry vertical is embarking on digital transformation. So, as I have been working in the industry, from the software engineer to CTO, Chief Technology Officer, everybody is talking about digital innovation, digital disruption, digital intelligence, digital economy, digital currency, all these things. So these digital transformation technologies are powerful enough to bring real business transformation. So we have been caring about many transformation in the past, business transformation through IT or computerization or something like that. That is some 30-40 years back. Now we are entering into the digital technologies enabled business transformation. So digital transformation, a very common term today, and there are several technologies that are enabling this digital transformation. Okay, so these are all some of the digital transformation technologies I used to talk in my talks everywhere. Okay, so but today, due to time constraints, I cannot focus on each and every technology that I have indicated, incorporated here. But you can clearly understand all these technologies. You might have had a lot of seminars, and you might have read about all these technologies in magazines, in journals. But these are some of the popular digital transformation technologies that I could take from Forrester, Gartner, IDC reports. Okay, so artificial intelligence occupies the top slot in really transformation, really bringing the transformation for all kinds of businesses across the globe, and analytics plays a very important role. Blockchain, that you might have heard about that, IoT, Internet of Things, so many other things, 5G, 6G, digital twins, cloud native computing, fog and edge computing, serverless computing, microservices architecture. So these are some of the most common technologies that enable the vision of bringing digitally transformed entity systems. Once upon a time, we might have heard about smart cities, smart homes, smart offices, smart hospitals, smart home, environments, all these things. Nowadays, with the flourish of digital transformation technologies, we are slightly changing the nomenclature. So we are increasingly using the word digitally transformed cities, digitally transformed homes, digitally transformed hospitals, digitally transformed hotels, kind of things. Okay, so we are giving much importance to digital transformation technologies and its use cases. So I will throw some light on artificial intelligence towards the end of the seminar, because I'm comfortable more with that artificial intelligence technology. Currently, I and my team are working on that. So, somewhere I might have written about AR, VR, that will be taken care of by Rahul Kumar. In between, I throw some light on Internet of Things. Internet of Things, all you know about that. Once upon a time, all our desktop, our server machines were integrated with Internet. That is Internet of Computers. This is long time back. That's why when we type timesofindia.com in our browser, we are able to access the Times of India server. That server may be located in some other parts of the world, but we are able to see all the news, latest news in our browser. Why? Because our desktop, our laptop are connected with the server that is somewhere in the internet. Okay. Then we came across Internet of Devices. That means all our devices are integrated with internet. That's why if you type, you can see your office emails in your mobile phone, because your smartphones are connected with the internet. So that is Internet of Devices. Then Internet of Services. Okay, so for example, once upon a time, if a company or if an enterprise wants to develop an application, what they have to do? They have to approach any one of the service-based companies like Infosys, Wipro, TCS, Capgemini, Cognizant, or Accenture, any service-based companies. So these companies will send the many types of people to those enterprises to start with requirements collection, requirements elicitation, requirements engineering. Then based on the requirement, they will start high-level design, then low-level design. Once the low-level design is finished, then they will jump into development using any one of the programming languages. Correct? So once the programming languages enabled programs are ready, then the testing team comes into picture. Okay, they will do a variety of testing, verification, validation kind of tools for enabling whether the software developed by the developers are free of any kind of errors. Okay, so that is testing or debugging. Okay, then once it got debugged, then it will be it will be delivered to the operator team, administrator team, so that administrator can run that developed software in a production environment. Okay, so once the operator started putting the software in the production environment, maybe a cloud environment, maybe our local cloud or private cloud, then it is visible across the globe. Anybody from any parts of the world can see your application. Okay, so that is a cloud enabled or cloud hosted application. So you think about that, starting with the requirements elicitation, then it will go to design, then development, then debugging, then delivery, then deployment. Finally, if the software is not needed, then you can go ahead with the decommissioning. Okay, so that is the methodology phases of software engineering. Okay, but with the microservices architecture, that is not the case anymore. Okay, typically for writing, for deploying a small application, the service-based companies would take months of time. Okay, because they start with multiple multiple things. Okay, starting from requirements elicitation. Okay, but that is not the case anymore with the microservices architecture. Already all the software components are written and stored in publicly available software repositories. They are written in multiple languages, maybe C, C++, C#, or Python, so many languages. Okay, you might have heard about Scala, Ballerino. Okay, so many languages nowadays available for each domain, for each application type. Different kinds of programming languages are being leveraged to develop your application. Similarly, for microservices architecture also, all the applications are segmented into multiple services, and these services are written in multiple languages. Okay, so what a developer, what a programmer, what a software engineer has to do here, when a team lead and a project lead or a technical lead says the developer saying that you have to build this application, then the developer has to understand what are the services to be incorporated in that application. For your kind example, take Flipkart.com. It's a massive e-commerce application. If you want to buy a books or dress, you go to Flipkart.com and you will use your credit card or debit card, whatever it is, you will buy those items. Similarly, Amazon.in, it's a very massive B2C e-commerce application. Now, these applications are comprising more than 1 lakh lines of software code. More than 1 lakh lines of software code. Okay. Lot of disadvantages, but due to the time constraints, I am not entering into that. But nowadays, these Flipkart or Amazon.com are slowly and steadily embracing cloud native computing. Okay. So I don't want to explain about cloud native computing. I just collaborated with a couple of engineers from IBM. I wrote a book on cloud native computing that was just last month released by IEEE USA. Okay, if you just type cloud native computing in Amazon or even in Google, you can get the details about that book. Okay, but I checked the price; it is very expensive, maybe around $122. I wrote to the publisher saying that $122 is a big amount for us people. As we are developing, it's a very huge amount. $122, if somebody has, he can buy a very, very nice smartphone. Why he has to spend such a huge amount of money for buying a book? You can't print that book in India so that it can be made available very easily for people to buy that book. But unfortunately, they clearly told it is not possible. It is printed in America, so it's very costly. So anyway, why I am talking about cloud native computing, these big e-commerce application, whether it is Flipkart, Amazon.in, they are slowly moving towards cloud native computing. That means they are segmenting that 1 lakh lines of code into hundreds of microservices. Okay. So what does it mean? For example, if you subdivide or if you segment Amazon.in, there can be hundreds of microservices. For example, a shopping cart microservice, okay, analytics microservice, payment microservice, notification microservice, okay. So cart microservice, product microservice, okay. All these microservices combined, and they will form a very huge, massive application for the people. There are so many advantages why we have to jump, why you have to embrace on my microservices. Lot of advantages are there. You might have heard about microservices architecture in the past. You will hear more about that because in the company, at least, if you are from company, you might have heard about microservices. You might have developed your applications as a collection of microservices. But in Geo, the first line from the CTO is every application, whether it is a mobile application, web application, IoT application, blockchain application, wearable application, enterprise scale business application, every type of applications has to be developed as a collection of microservices. Okay, so that cloud native computing, edge computing, I will throw some light during my second lecture. Serverless computing is another phenomenal automation over the current centralized computing model. Okay, event-driven architecture is another interesting thing. So augmented and virtual reality for Metaverse, you will hear more about that from Rahul. So very hot topic. Okay, so yeah, what are the implications? Now I talked about microservices. Today there are millions of microservices that are freely available. A developer has to understand what are the microservices to be part and parcel of a enterprise scale mission critical application. He has to download those microservices, combine them, cluster them together. You will get an application in minutes. So once upon a time, we are wasting months of time for creating an application. But with MSA, microservices architecture or cloud native computing, your application is ready in minutes of time. Okay, that is the powerful transition from the age-old methodology to develop your software application to the new world order of software application engineering. Okay, another thing is billions of connected and cognitive devices. I told about that we have 8 billion people. Last week, I read about that the world has reached 8 billion people, maybe 800 crores in our terms. Out of 8 billion people, 5 billion people are using mobile phones across the globe. Out of 5 billion people, 3 billion people are using smartphones. So that means we have already reached the number of billions of connected devices. But that is not talking about only smartphones, but also all kinds of devices within our home, within the hospital, within the manufacturing floor, in the factory, in the warehouse, in the healthcare center, in the playground, or in a eating joint, or an airport. All kinds of devices are getting connected with the internet. Okay, for example, you take your refrigerator at our home. The refrigerator is connected with the internet. What are the advantages? When the milk quantity inside the refrigerator goes down below the threshold value, the refrigerator will call the milk vendor saying that the milk quantity has gone below the threshold, so please supply 2 liters of milk. There is no intervention of human beings here. There is no involvement of human beings here. There is no instruction from human beings here. Okay, so that is fully automated. Why? Our refrigerator is connected. Our refrigerator is web enabled. Our refrigerator is cloud enabled. Okay, so that is the advantage of. So a couple of weeks before, I was giving a talk to NIT Trichy. Okay, so I was talking about this connectivity from 9 o'clock to evening 4 o'clock continuously with so many use cases. So so many other things. Okay, but I will jump into trillions of digitized entities. That means all kinds of common, casual, cheap things in our environment gets connected with the internet. For example, your door, your windows, your wardrobe, your cart, your chair, your table, everything gets connected with the internet. That's why I have written trillions of digitized entities. This is called IoT. Okay, this is called IoT. Internet of Things means all the concrete, tangible things in our everyday environments are getting connected with the internet. That is Internet of Things. I have written the word digitized entities. Okay. For example, when you are sitting your sofa will talk to the TV, saying that the gentleman is sitting on the sofa. So please start the TV. Now the TV starts. Suddenly there is a phone call for that gentleman. Now the phone will tell the TV saying that there is a phone call for this gentleman, so please reduce the volume. So you think about that, how sofa is interacting with the TV, how phone is interacting with the TV, correct? Otherwise, for the last 2 days, I was not feeling well. I am wearing the same dress. Now, when tomorrow morning, when I throw my dress into my washing machine, if I put a RFID tag on my dresses, my dress will tell the washing machine saying that this fellow used this dress for the last 2 days consecutively. So please go for deeper washing. That is the possibility. That is the fancy thing today, but we are heading towards that era. Okay. So what I'm trying to tell is all your common entities in our everyday environment will get connected with the internet. Why our door has to be connected with the internet? Why our windows has to be connected with the internet? Simple. when the door gets connected with the internet, the window can connect it with the internet, the windows will understand what is the outside temperature and what is the inside temperature. Accordingly, the window itself will decide whether to keep the window open or closed. Okay, that is a possibility. Okay, so we can list out so many things. Out of all these things, when trillions of digitized entities interact with one another, collaborate with one another, or when billions of connected devices interact with one another, for example, if somebody is coming to your home, you have put a security camera in front of your home, you are watching TV, the security camera that is outside the home will capture the image of the person who is coming towards your home. And the security camera will flash the image of the person who is standing outside into the corner of the TV because you are watching TV. Now the person who is watching the TV can see the face of the image who is standing outside, and he can orally instruct the door to open if the person is a known person. Okay, that is the advantage of having a connected security camera, connected TV. Okay, when I was with IBM, we developed such a adapter software for Philips TV. Okay, so what I'm trying to tell is security camera typically do not talk to TV because both are following different protocols. They are following different data transmission protocols. Okay, but through an adapter, through a middleware, it is possible for integrating security camera with the TV so that what is happening outside your home can be minutely captured and it can be displayed in the corner of the TV. Okay, so I can go on. So I will hand it over to Rahul. So he will throw some light on some light on VR and AR. Then after his things, I will proceed. Rahul, please take over.
Thank you, Peter, sir, for detailed explanation. It's always privileged to have you along with you as a co-partner for this prestigious presentations, along with the distinguished member of IEEE. I would like to thank Nirmal Das sir, Ramchandra sir, Chanchal sir, Sudeep sir, to give this opportunity to come as a panelist here and to speak something about as a technology. This is really something very prestigious part which we are doing it. And I am very much sure the attendees who is attending this call, they will take something from here. So this is our expectations. And anyway, if they found anything which is required to explain, they can put the questions. We'll try to help out, although the times are having the limitations. So we can.
Mr. Peturu, please unshare the presentation. Rahul, continue.
Yeah. Okay, sir. So continuing to the AR and the VR part, which is being always my favorite topics, which I was thinking to work upon. And let me give you the first background of the AR, how it came into the picture. So this augmented reality, always this is the dream of combining both physical and the digital worlds, because there are the lots of the things happening across our community which is not reachable to us. So how we can combine this physical world and digital world together? And this is something which is being developed in 1968. So you can imagine we are still now developing this cutting edge technology in the year of 2022, but this is something has been developed in 1968 in Harvard, where the computer scientist Ivan Sutherland, which is who was the father of computer graphics, he developed this augmented reality part. So that was something really very exciting, and nobody noticed because there were the lots of the things being developed. Mainframe machine was coming, computers was coming, then man to machine. In fact, technology was not supportive at all that time. So now we are at the stage where we can, because this to develop this technology, we need the larger amount of the bandwidth, reduced amount of the latency. That plays always very important role. So enterprise, when you will see the enterprise domain, they always seek to find the new approach to increase the workplace efficiency, how you can automate the process, how you can reduce the cost, how you can, this is the three or four most important things for every corporate, that how they can increase the efficiency by reducing the cost. So AR plays the very important role. Just I'm giving the one very practical example, like of the virtual training. Yes, people can say that yes, we can deliver the training through the Microsoft Team as well, through the Zoom as well. But with the effect of augmented reality, I will say the collaborations of the peoples are much more realistic onto this platform. People can collaborate with each other when you will put the AR headset on your headset, which is called HMD, head mounted display. When you will put it on your head, this will give you the immersive experience to collaborate with your other participants in much effective way. So this will help us to increase your efficiency, psychological counseling, and always our business model, which supports the enterprise market, is highly sensitive in the terms of ownership of the assets, especially with the relatively high rate of depreciation. Enterprise always look forward to turning heavy local technology, which is based on the cloud, which is the cerebral ones, so which will help to optimize their current revenue structure. That's why uh, AR is always important and the VR is always important. And there are the three major use cases, or there are the three major sectors which can be benefited from. In fact, other sectors can also be benefited, but most of the use cases where we can see the direct efficiency and the cost saving is the retail, manufacturing, and the healthcare sector. In fact, training is also one of the part, but yes, retail, manufacturing, and the healthcare sector, which will be being benefited to the most from this part. So now we can go to the next slide, sir. You, because this will, yeah, so this will, I will give you some basic view how this VR live broadcast is an example where the current approach is shown in the figure. So this is just basic architecture how this VR collaboration actually works. So what is happening basically here, we need, because human eyes are always susceptible to the some basic kind of pixels. So this virtual reality and the augmented reality part have proven themselves to for the valuable addition in the field of digital entertainment. So how this is happening? Uh, this is happening with the cost and the complexity of the computational systems. So what we are doing here, we are putting our view with the help of central processing unit, content delivery network, augmented reality, head mounted display, which is the wearable headset. What I'm talking about here, which is head mounted display, which is put on our, and with the support of infrastructure as a service, which is called the cloud, with the help of sensors, which is called the IoT, which is with the help of mixed reality, which is called the MTP. And one unique concept of here is the that is called MTP, motion of photon. So this will help us to connect your headset in the virtual world in much more effective way with the help of TPU and with the help of virtual reality. So now coming to the next part. So how this video part will come into the picture? This video part is something which is coming into the omnidirectional and the panoramic part. So this is the approach where natural scene is being captured with a special camera. This is not something the camera which we are talking about, which is being installed in your phone or something. This is the special camera where you can capture the natural scene with the help of camera and the microphone. And this analog to traditional conversion will be help with the help of unrestricted viewing. So computer generated synthetic environment will come into the picture and then forms the virtual reality. So there are the multiple use cases and the deployment also, which will cover into the next part of the slide. Sir, we can move to the next one slide. So yeah, just I'm giving one very good example of the use cases, because right now this is the use cases is being implemented by WHO, World Health Organizations, because they implemented this AR part to quit the smoking of the people. Florence is the one company who is promoting this AR part, how the people can quit the smoking with the help of AR. What they are doing, they are tracking the people, they are advising the people whenever they are feeling some gestures of doing the smoking. Immediately this AR part is with the help of sensors and with the help of the technology, they are giving some advice and they are giving some real time suggestions to what to do at the time of urge when they want to do the smoking and all. So this is the very good example towards the society, which is being very helpful and which is being already proven as a concept in our global market. Sir, we can move to the next. Yeah. So basically, AR is a presentation method wherein objects in the real world are very much combined with the digital world. So this is something what is happening. Uh, this is something. Uh, this is something very important in terms of presentations wherein the objects in the real world are combining with the artificial digital object, which can be either constructive or whether it can be either digital also. You can see the Pokemon Go game as well, which was the example of constructive AR experience. But this is something not being popular, or this is not something because there was so much risk got involved. So we took the VR as an also as in collaboration with the AR, so that this game should be much more effective, and there should be much, because we have seen some example where people are playing the PUBG and they are going to the VR environment, and some risks are getting involved and some major cause of the accidents we have seen into the past. So VR will help us to reduce this risk in terms of collaboration in much more effective way, putting the motion to photon motion MTP part, and tracking the objects in such much more realistic way so that this collision should not happen. Yeah, so we can move to the next slide, sir. Am I audible? Yeah.
Come on.
So this is something now we are covering the part of how this now we have everywhere the 5G buzzwords. So 5G is coming into the picture, how this 5G will transform the entire world. Yes, this is very true. We are talking about only about the speed and throughput. No, so speed and throughput is only one aspect of the 5G. Yes, we are getting the speed into the 4G as well. But yes, applications, developments, and other things which will be getting driven by the 5G is the one of the thing is the augmented reality and the virtual reality. But yes, this can be achieved only when we will reduce the latency in terms of bandwidth, latency in terms of our building the infrastructure, building in terms of, because the latency plays, because we are talking latency here, it should be less than 10 millisecond, because AR is something as a technology which requires the latency, and our core network should be managed in such a way so that there should be no bandwidth constraint, should not be there. High pipe of the bandwidth is required. Switching the application should be done between the less than 10 milliseconds. So these are the important criteria which should be met to deploy this AR VR. Because currently, just I'm sharing you the example, 4K panoramic video. 4K panoramic video, which requires 20 to 40 Mbps data rate with 50 millisecond latency. Since 5G network contribute to the considerable improvement in data rate, more than 100 Mbps we are trying to achieve in this 5G. So the latency should be less than 10 milliseconds. Then only user can enjoy more comfortable viewing experience. That's why 5G is coming into the picture. I have told you, we have explained in the initial of the slide. So this have been developed in the Harvard in 1968, but now we are into the 2022 because the ecosystems and the environment was not supportive to deploy this AR. Now we are at the right pace, globally at the par of rest of the world as well. So this is the right time to deploy the AR and VR, because we are getting 5G is promising. We have the 78, 79 band, which is much more suitable for 5G rollout, and which is much more suitable for our AR VR requirement also. Because see, the example is that for AR VR we need the 360-degree video resolutions. So 360 video resolution, you need the 60 frame rate per second. So to achieve this frame rate per second, you need the transmission which should be done at the rate of 20 to 40 Mbps, and latency should be less than 50 millisecond. But when you want to achieve the video resolution of 12,000 3D experience, like you want to do the shopping sitting into the India, you want to do the shopping in Dubai, so you need the 12K 3D experience. 12K 3D experience, for that you need the frame rate around 120 fps frame rate per second, which is on which coding rate will be S266. And for this we need the data rate should be 500 to 700 Mbps, and latency should be less than 10 millisecond. So this all criteria will meet into the 5G only. So that's why 5G is more suitable requirement, more suitable platform to deploy the AR and VR. So now we have to change our mindset. We are only talking about the speed and throughput. No. So we are changing the world through the AR, VR. Entire retail experience will be getting changed. Entire training experience will be getting changed. Entire manufacturing sector deployment will be getting changed. So these all things are coming together in a very aggressive way to change the consumer behavior, basically. Yeah. So we can move to the next slide, sir. Yeah. So ecosystem, when we are talking about the ecosystem, so why ecosystem is required to deploy the AR and VR? Because unless until you don't have the proper ecosystem into the space, you can't imagine to deploy this kind of the supportive technology into the real world. So that's why there are the 3 or 4 parameters where you need to work upon. Any service provider need, either it is Jio or it is Airtel or it is AT&T or Vodafone, any companies, they need to see these are the 4 or 5 parameters they need to build upon to deploy this air to this technology. One is the connectivity. Connectivity, already I have explained why the connectivity is important. Data rate will play the very important role to deploy this one. You need the reduced latency, you need the frame rate per second very higher side. For 12K 3D video, you need a higher amount of the bandwidth, 500 to 700 Mbps. So that's why connectivity is much more important. Now the components. When we are talking about the components, it means it's a hardware part, because the hardware is also equally important. Right now, like let us say we have built up our technology, we have built up our network, but we don't have the semiconductor, we don't have the chips to manufacture the mobile. So how this components will come, this component will play into the picture, because the hardware is also contributing 50% of the overall deployment. So components is equally important along with the devices. Sir, we can move to the next slide. Yeah, so devices, when we are talking about the devices, we are head mounted displays, which where AR glasses are there, and 360-degree cameras will be required. So these capabilities were built into the mobile phones. So we are working upon those. So where this the customer do not need to procure the separate mobile phone or separate headset for this itself. Mobile phone should be much more compatible enough with the help of AGI, with the help of other technology also, so that our headset and our mobile phone will be much more comfortable with the central processing unit. And battery will also play very important role, because this kind of the component requires the heavy battery consumption. So battery will be also play the very important role. And there are the 2 more important aspects which will play very, very heavily on deploying the technology. One is the slicing, another one is the jitter. So why I'm saying the slicing? Slicing is equally important, because we will going to browse the multiple applications in one go. So unless until slicing concept will not there, we will not be able to reduce the latency as in the minimum side, and the side, and the encoding and the decoding and the slice wise transmissions operations will not be happen. So slicing will play very, very important role. And apart from this, jitter is equally important. Sir, we can move to the next one. Yeah, so jitter, why jitter is important? Because whenever you are doing the encoding and the decoding part of the technology, so buffering should be done into this way, so that phase difference between data and clock should be onto the lower side. Because phase difference between data and clock, if it will be on the higher side, your buffering will be more, and once the buffering will be more, it will impact directly onto your transmission part. Because buffer sometimes frames to avoid the picture, and this your viewing experience will be impacted much more onto this side. So that's why buffering and this jitter, these are the important consideration which we need to take care for this technology. So these are the things. There are the multiple things which we need to take care. But yes, slicing and the jitter, why I have explained, because this will help us to reduce the latency. And once this will help to, and third part is the AGI, which Peter sir was explaining, and he will explain more into the coming part as well. So AGI, because it will help us to connect with direct. We do not need to require to connect with the centralized server. Edge AI will be there in nearer to our devices only, where our computational time or where our communication time will be getting reduced drastically. This is just like the concept of LEO Earth orbit, which we are talking about in terms of satellite communications and all. So Edge AI will play in the very bigger role, because all our infrastructure as a service, platform as a services, and the mobile edge computing with the help of edge node only, all the access network and all the carrier network, core network will be getting connected with the mobile edge computing only. So this central node will always play the complete control function and the control plane function and the management plane function of the 5G network. Especially this control plane will always help to for the service flow processing, policy scheduling, capability opening, network operation and maintenance, node management, and the slice management. So these are the very important role edge node and the mobile edge computing will play to deploy this VR as well. So this is something, yeah. So these are the things which I wanted to cover. Due to the timing constraint, there are some challenges as well, which are open challenges like physical place of deployment, ownership model, and there are some interfaces standardization will be also required. So these things also should be taken care of, being a service provider point of view, so that we are taking care of being a service provider company and being an, because parallel processing and to reduce the latency by the terminals, this is also very much important. So we are taking care of these things also to ensure the smooth viewing experience. So to reduce this buffering store, one in and one out technology will be there, where encoding will be done and the transmissions will be done. There will be the no concept of buffer stores, decoding will be done, and the direct screening will be there. So that technology will help us to reduce the latency as well. So that's all from my side, because in interest of time and my personal things are coming also on the way, since I'm covering this one from on traveling. So yes, this will be the great opportunity for me, and I will request everyone so stay in touch, and whatever if any information is required which I can extend my help, definitely I will do. Thank you all. Thank you.
So thanks, Rahul. This is a very good experience. I mean, you have narrated it very lucidly. Now it will be over to Mr. Petru. Please narrate the next part. Yes, Mr. Petru.
Yeah, are you able to hear me now?
Yeah.
Okay. Yeah. So thank you, Rahul, for explaining AR, VR, and how AR, VR are contributing for the for developing and deploying metaverse application. Okay. So yeah, my point is these two. So the web world is tending towards Web 3.0. We started with Web 1.0. That is just a static website, correct? If you see Times of India olden days, you can just read it. You cannot write anything. Now Web 2.0 came into picture. That is social web. So first one is symbol web. Second one is social web. Okay. So social web means you not only reading, but also you can write. So sorry, what is that? Twitter or Facebook or LinkedIn. These are some of the social media applications that are being categorized as Web 2.0 application. Okay, now we are getting towards another dimension, that is Web 3.0. Sometime back, Web 3.0 was categorized as semantic web. Okay, so but nowadays, after this metaverse idea came into picture, they have changed Web 3.0 to a different connotation. That means Web 3.0 is one of the primary infrastructure and implementation technologies for the metaverse applications. Okay, so I will throw some light on Web 3.0, then The second transition is the universe is getting towards metaverse. So you all know about Facebook has changed its name to Meta. Okay, so we can realistically understand how Facebook is changing to incorporate the metaverse features and functionalities in their delivery systems. Okay, I will throw some light on that. Yeah. Okay, so yeah, so as explained by Rahul, metaverse is a combination or convergence of physical world, virtual world, and augmented realities. Okay, where people appear as avatars that can interact with one another in a 3D virtual space. Okay, so it is metaverse is being categorized as an interoperable network consisting of real-time rendered 3D virtual world that can be accessed with the help of several AR, VR devices. Okay, so with the faster proliferation now, social media applications and distributed game, NFT is non-fungible tokens. So I throw light on that, and cryptocurrencies, people started to experience the full gamut of immersive and intuitive experiences with the virtual world. Okay, so I can go on talking about metaverse. So you simply understand that we are in the physical world. In the beginning, I talked about digital twin. I don't know whether I talked about that, but digital twins is one of the primary technologies in the digital transformation scenario. What is a digital twin? Digital twin is the software version or digital version or logical version or cipher version of physical entity. Okay, I have a friend from ISRO Bangalore. He is doing PhD now. When I was talking about this digital twin with him, he told in ISRO they are producing the software version of the satellite and rocket launches initially before building the rocket itself, before building the satellite itself. Okay, what do you mean by digital version? You have the software version of that particular physical object. The software version runs on cloud environment. What are the advantages? This through software version, you can understand what are all the features, functionalities, and facilities that can be accrued through that particular satellite or rocket. Okay, so before building that rocket and satellite, you can have the digital version. And what are the risks involved in developing particular satellite? For example, when two components in a rocket interact with one another, what happens? What are the risks involved? What are the additional capabilities and competencies that we can get when multiple components interact, collaborate with one another? Okay, so digital twin plays a very important role. Digital twins are the twins of physical systems, not only systems, but also process. Okay, so today all the complicated and sophisticated physical system have their own digital versions that are running on cloud. Okay, for example, if you go to a manufacturing floor or a factory, you can find a number of products, machineries in the manufacturing floor. All these machineries are sophisticated and complicated. Okay, so before building these machineries, it is better to have a software version. Okay, so the software version is, as I told you, runs on cloud, so you can understand everything. How to what are the new features that can be incorporated that you can understand through digital twins? What are the implications? What are the consequences of that physical object? And not only that, you can understand the real world interaction, real-time interaction. That means you can have a variety of sensors in the physical object. For example, you put a satellite. Another interesting example is the engine in all our flights. Okay, I was listening to the CTO of GE. He was explaining this very nicely. Every flight that travels from maybe Bangalore to New York, after 18 hours of travel, when the flight lands in New York, that data scientists, the artificial intelligence engineers will come to that flight to capture, to gather all the information that are generated by the flight engine. Okay, what is its performance, in what places it where it went through some oscillation, vacillation, some difficulties. Okay, so all these things can be captured. I'm not good at flight operations, so I could not tell more about that. But an avionics engineer can clearly articulate, clearly tell what are the important data points that can be captured by the AI engineers, data scientists from the flight, and the flight lands in New York, starting from Bangalore. Okay, so that is the possibility. Why? Around 800 sensors are there in each flight engine. 800 multifaceted sensors are attached in each flight engine. These sensors capture a lot of information on the way towards New York. Once it lands in New York, these sensors supply all kinds of information it captured during the flight. Okay, so these sensor data can be subjected to a variety of investigations by data scientists. Okay, so through big data analytics, through streaming analytics. Nowadays, now this analytics is slowly fading. Instead, now analytics is being accomplished through artificial intelligence. Okay, so that is the beauty of that. So what I am trying to say is digital twins is playing a very important role, very vital role in shaping up the world. Okay, so that's what I would like to tell. I can go on, but digital twins is one of the primary technologies for creating next generation metaverse applications. Okay, so that is the yeah. So what is Web 3.0? I told about that. The primary characteristics of Web 3.0 is it is decentralized. What do you mean by decentralized? Somebody asked me what is the difference between centralized application and a decentralized application and distributed applications. Okay, what do you mean by decentralized application? Simple. For example, these Web 2.0 applications are centralized application. What does it mean? If you are writing anything wrong, your account on Twitter can be easily removed by Twitter administrator, because the control is with the administrator, that is centralized. He can remove, he can add, whatever he wants to do, he can do it. Okay, you don't have power to get removed or to get added. Okay, that is the primary lacuna or primary issue of centralized application. Now, what is decentralized application? You can have the control with yourselves. Okay, for example, all the now you know about PNB, if I'm not wrong, that is the company name that is having a lot of hotels across the globe, even though they do not own any hotel. Okay, but they have the control over hundreds of thousands of hotel rooms across the globe. Okay, another interesting thing is Facebook. Okay, they can remove your content. Even though you are creating the content, but they can remove the content. They have the control, they have the governance, they have the management power with themselves. Okay, so even though you are the creator, you cannot do anything on that. Similarly, you take Uber or Ola. Even though Uber and Ola do not have any car, any vehicle in their repository, but they are the owner, they are the controller of hundreds of thousands of cars across the globe. Okay, that is the beauty of Web 2.0 social media application. But Web 3.0 is decentralized. You own the car, you have the control, you have the management power, you have the governance with you. Whatever you want, you can do it. You can add, you can remove, you can, whatever you want, you can do it. That's the first thing, decentralized application. You might have heard about when you had some lectures on blockchain. Decentralized is the primary property of blockchain application. What do you mean by decentralized? For example, today, if I want to send some money to Rahul, what I have to do? I have to go to my Citibank page and I have to create an account or something like that for Rahul, and I can send the money because Citibank guarantees the trust. whether the money that I'm sending actually reaches Rahul. Okay, that is the beauty of having an intermediary. That is the beauty of having a bank in between two users. That is, the control is with the centralized intermediary bank. They can do whatever they want to do, even though they are guaranteeing the trust, or they are guaranteeing the competence of sending your data or your money to the other party in the other side. Okay, so decentralized means there is no need for intermediary. Okay, there is no need for bank. I can send directly to Rahul, whatever amount I can send it without botheration about the centralized bank. I have the trust. The trust is being enabled through the blockchain technology. Okay, so that is the idea. So I told something about blockchain also. Cryptocurrency, all we know, Bitcoin is one of the cryptocurrencies in the world now. In the Web 3.0 world, the flat currency, that's what we are every day using, our cash, our digital currency, that do not have any validation in the Web 3.0 world. Instead, your value gets converted, it gets transmitted to the other party, P2P, peer-to-peer, through cryptocurrency. Okay, so if you want to send some money to the other party, when in the Web 3.0 world, my cash, my digital currency has to be converted into cryptocurrency. Then only I can play around with the cryptocurrency in the world of Web 3.0. Okay, and autonomous, lot of manual activities gets automated through AI. Okay, that's what I have written. So these 4 properties distinguish Web 3.0 from the previous web versions. Okay, you can clearly understand that. So cryptocurrency, blockchain, decentralization, and autonomous are playing very important role in creating and sustaining Web 3.0. Okay. Yeah, so I told about web, semantic web. What is the difference between semantic web and syntactic web? The Web 2.0 is actually syntactic web or social web or something like that. Okay, because syntactic web is based on keywords. For example, if I type banana chips in Google, it will show all kinds of chips, banana chips, microchips, all kinds of chips. Okay, but in the Web 3.0 world, if I type banana chips, then Google will understand, okay, this guy is an IT guy. Most probably he will check only for microchips. Okay, so that is based on meaning. That's what I have written. Instead of using numbers and keywords, the semantic web is primarily centering around word understanding. It understands the word, it understands the context, and accordingly it will search for the correct links or pages or portals, correct? So, for example, you might have heard about RDF, you might have heard about ontology. These are some of the technologies that are being utilized for developing Web 3.0 or semantic web. Okay, when I say context, there is an interesting phenomenon. For example, at 1 o'clock, when I'm walking on MG Road in Bangalore, I will get a message in my smartphone saying that it is already 1 o'clock, you should be hungry. Okay, if you walk another 100 meters and if you take a right turn, you can enter into Brigadier Road. In Brigadier Road, you can find KFC or McDonald's or Subways, and these are all the items available on these restaurants or cafeteria. Okay, you can order them. You can all these things. You will get the message in your cell phone. That is just location-based services. What is context-based services? Suppose on Sunday morning, if I am inside the church, if there is a phone call for my cell phone doesn't ring immediately. What the cell phone will do, cell phone use my camera to understand what this guy is doing, with whom he is interacting, what work he is doing, what is the mood in which he is there, whether he can accept any call at this point of time. All these things it will analyze by themselves, and it will tell the caller saying that, please do not disturb him for the next 1.5 hours. Okay, so that is context our services. Hearing, semantic web plays a very, very important role. Okay, that is the distinction you can clearly understand between Web 2.0 and Web 3.0. So that is one aspect. And trustless, you might have heard about zero trust. That means no access or nobody will be trusted in this trustless environment. Every person or every request, every transaction has to go through proper authentication, authorization kind of thing. Okay, that is the phenomenon behind trustless. Okay, so that users can access public cloud or public internet or private cloud or private internet without exposing them to any kind of dangers. Okay. And the third one is in the Web 3.0 world, all the IoT sensors. When I talked about IoT, there are already trillions of Internet of object things, correct? Trillions of digitized entities, trillions of digitized objects. Okay, so these objects gets connected with the internet. Okay, that's a huge, that's very massive, tremendous, Himalayan task. Why? So today you take all the cloud environments. For example, Amazon is one of the largest public cloud environments. I am talking about the statistics that was published maybe a couple of years back, maybe 2020, just before Corona came in. Around 4 lakh servers are there in cloud in Amazon cloud environments. So Amazon cloud has around 13 regions. Again, it's a old data. Maybe they might have increased the number of regions, and they have a number of availability zones also around 45, if I am not wrong. Okay, so if you sum all the servers that are there in Amazon cloud, it is around 4 lakh servers. Maybe now they may have increased to 5 lakh servers. Google is the largest public cloud service provider with 8 lakh servers. Azure has around 4 lakh servers. Then Oracle, IBM, Alibaba Cloud, Huawei Cloud. Okay, there are several other public cloud service providers. If you sum all the servers in these cloud environments, it comes around 20 lakh servers. That is 2 million cloud servers, 2 million cloud servers. Now, if you take the number of devices, as I told you in the beginning, there are already billions of connected devices, billions of devices integrated with internet. Okay, 1 billion means 1,000 million. So I have a laptop given by Jio that has 16 GB memory, but I have a cell phone with 8 GB or 12 GB memory. Okay, so my smartphone is also almost equivalent to the total memory my laptop has. So slowly and steadily, our edge devices, our IoT devices, our connected devices are also having enough memory, enough storage power, storage capacity, enough processing capability. Okay, so what I'm trying to tell is, with 2 million servers, when we combine with the billions of connected devices, think about once upon a time only 2 million servers were connected with internet. Today, billions of devices getting connected with internet. Tomorrow, when trillions of digitized objects get connected with internet, think about the massive internet. Okay, massive size of the internet. It's very complicated. You do not know who is talking to who, through devices, through digital objects, through server machine, through laptops, through desktop, so many things. Okay, the possibilities and the opportunities are very huge when you are all the IoT sensors, devices are getting connected with the internet. Okay, so Web 3.0 will have such a huge complexity, which is with a huge complication. Okay, and the security is very unpredictable, indeterministic. Okay, so third one is 3D graphics are used. Okay, today if you go to Amazon.in, there is a virtual environment. You can go select the products and you click the you submit your credit card information. In 1 day or 2 day times, you will get the products at your door steps. Okay, that is you can that is virtual tool. That means virtually you are not touching the physical object, but you are seeing that, you are feeling that. Okay, so that is the power of. But in future, 3D graphs, you can see the products in 3D version. Okay, so that is the beauty of 3D graphics, 3D modeling, 3D construction. All these keywords are associated with 3D. That will be part and parcel of Web 3.0. Okay, so now 5 o'clock, 5:20. Okay. So now I don't dwell deep into Web 3.0. You can go through that in your leisurely. I throw some light on Web 3.0. It will be beneficial for you people to go deep into this Web 3.0. Okay. So blockchain technology also very interesting technology. Today in Geo, we have started a blockchain technology center of excellence. Some technical experts and evangelists are being recruited, and they are focusing on blockchain technology. One of the projects that I was told is do not disturb. Today, every day your phone rings, correct? From all kinds of banks, insurance, money control, all these things. They will tell we have personal loan, you have credit card, and other cards. Okay, because they have our number, they are disturbing you, they are irritating you at all the times. Okay. What is do not disturb? There is a decentralized database. Therein, if you put your cell phone, any call that is destined for you has to be routed through this blockchain decentralized ledger of all the phone numbers. So in the ledger, if you indicate do not disturb, okay, you will not get that call. Okay, you will have the call only from the known people, only from the authorized and authenticated people. Okay, but still I'm getting that call. I was told already we have submitted this project to the central government. I do not know what is the status of that, but still today also I got some calls from money control or something like that. Okay, so there are so many other blockchain projects. Even the government of Andhra Pradesh, if I am not wrong, I read it in the newspaper. They are using this blockchain technology for real estate or for storing all the land records, so that nobody can manipulate land records to sell those land, okay, to somebody else in an illegal or in an unauthorized manner. Okay, so lot of new applications that are coming up in blockchain. You might have heard about that, but I don't go into that. But lot of automation, lot of transformation is being brought in through blockchain. Okay, so the primary advantage of blockchain is establishing and ensuring data security. Okay, your data is being fully secured. Nobody can touch your data, can see your data. Okay, the confidentiality, the integrity of your data is being fully established and enforced through the blockchain technology. Okay, so a lot of things. Blockchain plays a very important role in Web 3.0. As I told you, cryptocurrency based interaction transaction happens in the Web 3.0. So that cryptocurrency is one of the primary applications of blockchain. Okay, of course, cryptocurrency is not doing well even across the globe. Okay, very recently one of the prominent cryptocurrency company got closed down, if I'm not wrong. Even our central government has not allowed cryptocurrency companies to thrive, survive in our nation. Okay, there are little bit dangers associated with the cryptocurrency. They are thinking that terrorists can enter into our nation through such kind of cryptocurrency, something like that. I'm not sure how, but anyway, there are some reasonable fears about the cryptocurrency. So world countries are also hesitating, they are having second thoughts on allowing cryptocurrency in there. Also, it is in topsy-turvy manner. Today the value goes up, tomorrow the value comes down, lot of losses, lot of gains, so many things. So till the technologies become a matured, stabilized one, the faster proliferation of cryptocurrency is doubtful. Okay, so it will take some time till the technology becomes a matured commodity. Okay, so that is the primary thing with the blockchain, but blockchain is totally different because not only on cryptocurrency, across many domains, blockchain is being utilized. For example, to securely send your patient data or insurance data or financial data to across the globe, across the continent, across the country, across the cities or across the counties, it is possible to use blockchain. So blockchain is tremendously powerful technology. It is going to shine the days to come. Of course, cryptocurrency may be doubtful, but typically blockchain is a powerful pioneering technology that can be leveraged across multiple industrial verticals. Okay, so yeah. So NFT, NFT is non-fungible tokens. Okay, so you are creating a lot of digital art or digital assets. Similarly, real assets. For example, if you click a very powerful shot played by Surya Kumar Yadav yesterday or day before yesterday, you can keep it as your own digital art, your own digital image or digital asset. Nobody can copy that. Nobody can manipulate that. How? All your physical and virtual assets can be tokenized. That tokenized can be done through blockchain technology. So what does it mean? Nobody can do anything with your digital art that got tokenized without your permission. You are the sole owner of that digital art. Nobody can buy that. Okay, all our film stars. Okay, I don't know much about cinema, but I read it in the newspaper. If I am not wrong, some popular cinema stars in the Hindi belt, they are generating a lot of NFT, non-fungible tokens for their arts or collections, and they are keeping that for their own use, and they can sell it for a huge amount. Okay, that is the possibility of NFT. So NFT, the underlying technology is blockchain. NFT can be used across not only digital asset, but also physical asset, your land, okay, your phone or anything. Okay, that is the beauty of NFT. You can go through that. So your image, your audio, your video. Suppose if you have taken a photograph with one of your favorite cricketers or film stars or any other important VIPs, okay, you can convert that into NFT so that nobody can copy that without your permission. You can sell that for a huge price. Okay, that is the advantage of NFT. Why I am telling all these things? These are all part and parcel of the implementation technologies of Metaverse. Okay, started with the digital twins, then NFT, blockchain, Web 3.0, cloud, okay, IoT, and edge computing. All these are the phenomenal technologies that contribute for the development of the Metaverse. Okay, so AR and VR again, that is the fundamental, foundational technologies for creating Metaverse application. You heard a lot about that from Rahul. So you can have a very interesting thought process or reflections on these things. Okay. What is this? Internet of Things. Okay. So what is Internet of Things? As I told you, all kinds of sensors. Okay. If you go to Kaichipi, there is a page called, they have indicated by 2025, another 3 years, there will be 2 trillion IoT objects, IoT materials, okay, IoT entities, elements, okay, that is the statistics by Kaichipi, okay, 2 trillion. So that's why I used sometime back trillions of things. So I think I can talk for another half an hour till 6 o'clock. If I have to finish it little before that time, please tell me. I will immediately stop my lecture. Okay. So IoT sensors plays a very important role because it's all about, for Metaverse, it's all about creating virtual environment. Okay. For example, I I come across one interesting thing is, you go to Amazon.in or Flipkart.com, you buy a dress. Okay, you can see all kinds of dresses in 360 degrees. Okay, but you cannot have the fitting room in Amazon.com. Okay, for that you got to go to a physical store. You go to a physical store, you buy you take an item, you can go to a physical fitting room, you close the door and you can you can wear that dress and you can see it everything, correct? How it looks in the mirror inside the fitting room. But in the metaverse world, in the virtual world, if you go to Amazon.com, you can not only buy those items, but also you have a virtual fitting room in Amazon. It is not there at this point of time, but in due course of time, you will come across virtual fitting room. So that's a prime example. You go not only by choosing or buying items, but also you can wear it, you can check it, whether how it looks, all these things virtually. Okay, that is the beauty. You need not visit any physical store to see how it looks, how it fits for your body, all these things. It is possible. That is because of IoT. Why? Because IoT sensors will send a variety of data to your VR headset or head-mounted display, HMD. Okay, that's what Rahul talked about. That. Okay, when you wear that, you can virtually fit your dress, and you can see whether it fits very perfectly, and then you can buy that item. Then you can buy that dresses, clothes, kind of thing. Otherwise, if you go to IKEA or any other furniture store, what you can do, you can buy a furniture home in a physical world, but through AR. I am not talking about VR here. VR is primarily working on virtual world. You are not stepping out of your home. Instead, you go to a virtual environment like Amazon or Flipkart, and you can work it out many things. But in the AR world, that's the opposite. That is, you go to a physical IKEA store or any other furniture store, and you go there, you choose a furniture, and now through AR devices, what you can do? Now you can choose a furniture that you can check whether that furniture, how it looks in your home. Okay, you are in a furniture storeroom, you are not in home, but still it is possible through AR, you can see your furniture, how it fits inside your home, where you can put that furniture in home, in your dining hall or main hall or your bedroom or wherever it is. That is possible through AR, augmented reality. So the primary difference is you are augmenting the virtual world through VR, you are augmenting the physical world through AR. Okay, so that is the main difference between AR and VR. You are creating a metaverse world through AR as well as VR. Okay, and the basic thing is different. In the virtual world, you are enhancing the interactive, immersive, intuitive experience through VR. In the physical world, you are enhancing the virtual things or digital things through AR, augmented reality. That is the difference. IoT plays a very important role. So that's what I have written here. These IoT sensors are integrating with your VR and AR devices. For example, I was going through a research papers that was sent by IEEE for reviewing. There was a paper titled on ambient assisted living. Okay, ambient assisted living. What is mean by ambient assisted living? In advanced countries, not in India. Here we have a lot of population, so to take care of our elders. Okay, for taking care of my mother. But in the case of advanced countries, developed countries, there are very few people. So there is nobody to take care of elderly people, debilitated people, deceased people. They are living alone. Suppose that lady or gentleman lying down on the bed, he or she wants to have a cup of coffee. She or he wants to have a cup of coffee. 1 second. Yeah, she or he wants to have a cup of coffee. Okay. What she can do, she can take a mobile phone and she will order a cup of coffee with a coffee maker. That coffee maker is in kitchen. She's lying down on the bed in the bedroom. Okay. So now she can order a coffee maker to make a cup of coffee. Now, once the coffee maker finishes the coffee making activity, that coffee maker will send a message to the humanoid robot. That robot is located in some other place within the home. So the robot will slowly goes to kitchen to collect or fetch that coffee to the bedside of this lady lying down on the bed. Okay. What I'm trying to tell is the interaction. Okay. These can be enhanced through AR and VR. Another thing, when she wants to go to bathroom, suddenly she falls down, okay, on the ground or in the bathroom. How it can be identified? There is a camera. Whether she deliberately sits on the ground or she accidentally falls down on the ground. That can be understood through this AR/VR application that is running on the camera. Accordingly, that camera will send the message to the caregiver or the doctor, so that the doctor or the caregiver from a remote place can fast come to this lady room and they can take care of that lady welfareness. Okay, so that is possible through such kind of the camera integrated with the VR AR devices. Okay, so that is the thing. So we can go on like this, but unfortunately I have never used these AR VR devices, but Geo has couple of years back introduced a Meta glass, if I'm not wrong. Maybe Rahul knows about that. I was seeing it through an online demo given by our CTO a couple of years back. Okay, he was wearing that glass and he told he can experience the 3D version of the environment or a 3D version of the activity that's going on. So, so several years back, somebody visited this cinema theater. Okay, I didn't get any experience to visit cinema theater, but he told in there are 3D films or something like that that can be visualized through wearing that glass or something like that. Okay, so think about that. That kind of things happen because of the integration between IoT sensors and the VR AR devices. Okay, so yeah, IoT plays a very important role. Edge computing. Okay, so I think Rahul throws some light on this. What is edge computing? For example, what's the time? 5:40. Another 20 minutes I will take. Please wait. Okay, so edge computing. Now I am leading that edge AI division in Geo. Several years back, an Indian professor, he's still a professor in Carnegie Mellon University in USA. His name is Professor Surya Narayana, some name. Okay, he is the author of the world, the originator or the first mover of this computing called edge computing. Okay, so what is the use case that motivates him to formulate the word edge computing? You might have heard about fog computing also. Conceptually, there is no difference between fog computing and edge computing. If you ask a Cisco guy, he will say fast computing. If you ask a IBM guy, he will say edge computing. But now the word edge computing came into existence. All the countries across the globe are using the word edge computing. Okay, so what is edge computing? Suppose I visited Calcutta when I was doing my PhD to ISI Calcutta, maybe in the year 1997 or something like that. Okay, so now I take an example in Bangalore. So if you know Bangalore a bit, there is a junction called Silk Board. Okay, it's a very complicated junction. The traffic will definitely. Okay, if I go to my office in Bangalore, I can the distance is only 10 kilometers. It takes minimum 1 hour for me to reach my office. Sometimes I spend 1 hour in Silk Board Junction. Okay, I got to crisscross Silk Board Junction. So what I'm trying to tell is, in the Silk Board Junction there are cameras. Okay, junction, the cameras. This is not a possibility in India because still cows are crossing the road in Bangalore. Okay, so I was working with, when I was working with IBM, I collaborated with one architect from IBM Smart Cities division to write a book on intelligent cities. Okay, so we wrote the book on smart cities, but at the final minute, I've been told we are using the word smart city, so you cannot use the word smart cities in your book. So we had to change the name to intelligent cities. Okay, so when the government, central government came to rule, they told we will create 100 smart cities in India. Correct, if you recall correctly. But as far as my knowledge is concerned, there is no smart city in India. After several years, I met that architect. She left IBM and she is a head in some other company, Confidential or something like that. Okay, I asked her, Anupama, what happened to the smart cities project initiated by the central government? She told, sir, it is not possible because even now cows and buffaloes cross the road. So we cannot, we can dream only smart cities in India, but not the reality. Okay, what I'm trying to tell is, come to edge computing. So this is a use case happening in advanced countries. There are cameras in every junction, and along the road there are electric poles. In each electric pole, they will have a Wi-Fi gateway. Okay, so now people are crossing that signal. Now all the cameras that are there in that signal will capture the images of the person, people who are crossing the road. It will calculate how many people are crossing the road at that particular point of time, at what speed they are walking, they are crossing, they are all these things, and it will send that images or the data collected to the nearby Wi-Fi gateways that are there in the electric poles. In the Wi-Fi gateway, you can run an artificial intelligence software. That artificial intelligence software immediately crunches the data, collects the data, clean the data, crunch the data, and it will come to the conclusion, and immediately it will send out a message to the incoming truck driver, car driver, bus driver, biker to slow down the speed because people are crossing the road. Okay, so this is called edge computing. Why? Because computation is happening locally. That is, the data captured by the camera is not sent to the faraway cloud. Okay, so that is the difference. So olden times, the data gets captured by the cameras, and that cameras send the images to the faraway cloud through the internet, and the processing happens in cloud. By the time the car would have crossed the signal, correct? Because it has to send the data, process the data, respond. Okay, sending, processing, response. It will take a lot of time. It will take maybe microseconds or maybe seconds. By the time the lorry or truck would have crossed that particular signal. How to do nano second processing? What is the methodology? What is the mechanism? What is the workaround? You have to locally capture the image. Locally, you have to do the computation. That is done through that Wi-Fi gateways. Nowadays, we have AI-enabled cameras. If you go to airport, the cameras itself fit with the AI application, AI models inside the camera. So if there is a terrorist entering into that airport or railway station, immediately the camera will capture the image of that person, where he is walking, in which speed he is walking, all these things it will capture, and it will immediately tells the policeman managing there, saying that there is a terrorist entered into the airport, he is walking towards this destination, this is, it will send all the metadata about that person. So immediately police people can plunge into the action to catch hold of him. Okay, that is the idea behind edge computing. That means computing happens at the edge. Okay, it is not happening at the cloud. Okay, but for that we need AI application that has to run on edge devices, IoT edge devices. Now, as I told you, IoT edge devices can be categorized into two main segments. One is resource-constrained IoT edge devices. Another one is resource-intensive IoT edge devices. This typical sensor, we cannot run any AA model on that, because it will not have that much memory power, storage power, processing power, or network. Okay, it will pass on that data only for 20 meters based on the protocol that is being utilized. But there are devices, IoT devices, connected devices, or networked embedded systems that have enough memory, that have enough processing power with the CPUs, GPUs, TPUs, NPUs, NPUs, okay, tensor processing unit, vision processing unit, neural processing unit, GPU is graphical processing units. These processes are very even NPU, or if I'm not wrong, can do trillion floating point operations. Okay, that is it can do a large number of computations in second. Okay, that's the power of the latest AI-centric processes. Okay, so these devices with such kind of processing units can collect the local environment data, and they can crunch the data immediately, and they can take the action without waiting for any human to instruct, to intervene. Okay, that is the idea behind this edge computing, or edge AI, or on-device processing, edge intelligence. These are some of the buzzwords that are going around in the edge era. Okay, so edge computing plays a very important role, because if you go to IKEA and if you check a furniture, this furniture is being visualized or assessed through your AR device. That AR device is having such a edge AI application, then that AR device will collect all the data about that furniture, when it was manufactured, who manufactured it, how long this furniture is there in that storeroom, how long it can be utilized, what is the brand name of the manufacturer, what is the rating for that. You can find all the meta information about that particular furniture. Plus, you can visualize how that furniture can be put inside your physical home to see how it contributes, how it looks, how it interacts with other devices in the vicinity. Okay, all these things can be calculated. How? Because of edge computing. So edge computing plays a very important role for the metaverse world. Okay, so 5G, very interesting. Rahul throw a lot of light. Primarily, 5G is maybe 100 times faster than 4G. Another interesting thing is, for example, if I go to a nearby mall, okay, when there are more number of 4G devices, we will get a call drop. Okay, but that can be solved through 5G, because 1 million devices can be accommodated in 1 square kilometer area. But theoretically speaking, only 10,000 devices can be accommodated in 4G. But 1 million devices can be accommodated within 1 square kilometer area through 5G. That is the power. So your reliability goes up, your availability goes up. It is very fast, 1,000 times or 100 times faster than 4G. Okay, so that is about 5G, and 5G is very important for metaverse, because the interaction in the interactive experience that is being promised by metaverse has to be real time. Okay, if there is a small stagnation or procrastination, then you will not see that interaction very useful, very intuitive, very informative. Correct? So interaction has to be very real time. When you touch something, immediately you got to see the digital information of that physical object. How it can be possible? Through private 5G, industrial 5G, or even cellular 5G. Okay, that is possible through 5G. So similarly, there are so many other things. For edge computing also, 5G plays a very important role. I think I have only 10 minutes. So one project work we have done is, I work for Bangalore office before Corona. When I go to office, I will swipe my ID card in the door reader of that building. then the door reader will capture all the information in my ID card. It will send that details to the Kaichar application. That Kaichar application is running on Navi Mumbai cloud. Okay, now it is exactly 1,000 kilometers between Bangalore and Mumbai. Okay, if you have flown in flight, you might have seen that number. We have to travel 1,000 kilometers between Bangalore and Mumbai. Okay, now we think about that 1,000 kilometers. The data has to travel from Bangalore to Navi Mumbai. In the Navi Mumbai, all the data gets matched, compared with the already developed HR databases. If it is matching employee ID, face, and other things, finally say yes, then the response comes via again through the internet. Till then, I have to wait outside the room, wait outside the office. So finally, the door will open so that I can resume my official activities every day. Okay. Now the question is, suppose the internet is down. Suppose the cloud is down. What will happen? I have to stand outside the office infinitely. Okay. What is the solution workaround? So, so at that time, I was reading about the research paper on edge computing and other things. So I proposed a solution to the management. So they immediately accepted. Today we have developed a edge controller. This edge controller is made up of a Raspberry Pi. It's a very small device. You can, it will be like our palm. Okay. This edge controller can store the 55,000 employee details. Okay. 55,000 employee details. So that every floor, every building in RCP, that is the headquarters in Mumbai, has this edge controller. We have applied for a couple of patents on this edge controller and the idea. So I'm sorry that I could not share more information about the technologies we have used. What is the in-memory database that we have used there? What is the advantage? This edge controller is very near to the door, only just 7 meters or 8 meters away from the door. So when I go there, swipe my card, that data gets captured and it is sent to the edge controller that is just 8 meters from my door. In nanosecond, the door will open. Why? Because the data is not being sent to far away cloud. It is sent inside the, it sends the nearby edge controller. In nanosecond, the door will open. Okay, so that's the beauty of edge computing. That edge controller is connected on both connectivity, wired connectivity as well as wireless connectivity. Okay, Zigbee protocol is also being supported. Similarly, wired connectivity also given. We have given. So suppose wired connectivity fails. Wireless connectivity comes into picture, something like that. So once again, my boss told us why you are still sticking to ID card that has to be hanged around our neck. So we incorporated face recognition module inside that edge controller. So what does it mean? There is a CCTV camera in every door. Just to go there, you need not carry your ID card. You go there, in which direction you are walking towards the door, that CCTV camera, 360-degree CCTV camera can turn around and it captures your image. That image goes to that edge controller. There it will be combined with the database images, and in nanosecond it will open. But today we are facing some challenges. We are not achieving 100% accuracy. Okay, it opens for some people. It is not opening for some other people due to the algorithm, face recognition algorithm that we have utilized. We are trying to enhance the accuracy. Till we reach 100% accuracy, we have to still carry the ID card in our neck. Okay, so that is the project that is the combination of 5G and edge computing. Okay. Yeah, digital twins, I told about that. For every physical entity, there is a corresponding digital entity. Okay, that's a corresponding software version. Today, software version is running on cloud. So any machinery that is in the factory floor has to send the data to the digital twin that is running in the cloud by sending the data through hundreds of kilometers away from that. But tomorrow when we have edge cloud, okay, edge cloud means today how cloud is being formed. Cloud is the collection of hundreds of thousands of server machines. I told about that sometime back, but edge cloud is being formed out of devices. The device will multiple devices combined together, club them together, fused together, blended together to create a edge device cloud. Okay, there are technologies like Kubernetes, okay, containers, microservices. You will hear more about that. Edge cloud is already there, but edge device cloud is picking up. Several years back, one of my PhD students created edge cloud at his home. He connected his refrigerator, his smartphone, his laptop, his Wi-Fi gateway together within his home to create an edge cloud. Okay, so that is the thing. So today technologies are made available. So edge cloud can become a very new normal in the years to come. So these edge computing, 5G, then digital twins will help in creating these applications for metaverse world. Okay, so I have written about how digital twins help in the formation or in the formulation of metaverse application. I have written about that here. You can casually and comfortably go through the slide to understand more. I go fast. What is this? Yeah, so there are a lot of advantages of digital twins and metaverse in the industrial sector, manufacturing sector, automotive. For example, you can create a. You need not go to a car. What is that showroom to see how a car looks? You can go to a virtual car showroom. You can see everything because that's the combination of digital twin and metaverse. Through VR and AR, you can see the multiple dimensions of the car from sitting at your home, so that you can take the final buying decision very fastly with all the confidence, with all the clarity. Okay, that is the power of digital twin and metaverse. Similarly, retail and e-commerce, I explained about virtual fitting room, smart architecture. That is smart cities have a lot of buildings, a lot of structures, how they can be developed, how the new architecture can be developed for the building, so that the sustainability goal imposed by various nations across the globe can be fulfilled. Okay, the carbon footprint of new machineries, new structures can be minimized through this combination of metaverse and digital twin. Okay, so so this is about virtual reality. You heard about a lot from Rahul. This is about augmented reality. Okay, this is about artificial intelligence. So I will spend another, I am almost 6 o'clock. Okay, so I will throw some light on AI and I will finish my things. So actually I have, my target was to list out all the prominent pioneering technologies for creating the dreamed metaverse world. Okay, so metaverse world is slowly and steadily coming up with the availability of competent state-of-the-art infrastructures and cutting-edge technologies. So one of the cutting-edge technologies is artificial intelligence. Okay, so but people have different definitions about artificial intelligence. Yesterday I was giving a lecture about artificial intelligence to a college in Tamil Nadu. Okay, so I throw some light on that. So I will spend a couple of minutes on that. Anyway, you can go through that. When we say artificial intelligence, it's a collection of technologies and tools for replicating human brain like capabilities into our everyday machines, our everyday software applications. So that is the overall understanding about AI. So AI is a collection of technology that will help your ordinary items, your devices, your cell phone or your machineries or your drones or your robots or your cars, okay, to be intelligent in their actions and reactions. How to do that? There are two prominent technologies for AI, that is machine learning algorithms and deep learning algorithms. Machine learning algorithms are typically popular in certain application like classification, regression, clustering, association. Okay, deep learning algorithms are good at some other applications like detection, recognition, tracking, summarization, translation, captioning, some of these things. Okay, that is through DNN, deep neural network, whereas the trivial or the base application like clustering, classification, regression are being accomplished through machine learning. So, what are the AI technologies? Machine learning and deep learning. Now, what are the AI application? That is through CV, computer vision and NLP. How you can see an image, you can do a lot of things on. Yesterday, I was interviewing a girl student for my division. I asked her what is the difference between image processing and computer vision. Okay, she has completed BTech computer science and she has 3 years experience also in one of the prominent companies in India. But she could not clearly articulate the difference between image processing and computer vision. So I tell the computer vision is all about you can understand, you can manipulate, and you can see what is inside that image, whether there is any person image, cat image, dog image there, how to do boundary box illustration of that. So you can detect some objects, useful objects in that, and you can track the objects in which direction that is traveling, all these things. So that is about computer vision. That is image processing, just it will do some processing. You can cut and paste, or you can enhance, you can do some operations on that image, but you cannot understand what is inside. And above all, you cannot do any analytics on that objects that are inside the image. That is the difference. Okay, computer vision not only detects, but also it can analyze that vision data. Okay, so that's what I told you. When you put some computer vision enabled model or application inside your camera in the airport, then your camera can analyze the images captured locally and understand, okay, there is a terrorist entering into the airport. Then immediately it will connect with the nearby policeman to tell him about this. What is that person entering inside the airport. Okay, so that is about computer vision. NLP is we can talk with missions in our natural language. If I talk in English or in Tamil, that system or that machinery can understand my language, and it can respond to me in my own natural mother tongue. That has the capability because NLP. We are all leveraging a lot of NLP technologies like BERT. Okay, bidirectional transformation. What is that? I forgot the full form, but BERT. Okay, if you type BERT in Google, you can easily understand that. Okay, there are so many varieties of BERT, tiny BERT, small BERT, so many other things. Okay, so that is about NLP. So these two are the prominent applications of AI. ML and DL are the prominent implementation technologies of AI. So AI is an umbrella term. People always say AI and ML, something like that. That is the correct connotation. Instead, when you say AI can be implemented through ML, AI can be implemented through DL. And what are the prominent application? ML helps to develop classification kind of application, and DL helps to do image recognition, video processing or analytics, all these things. Okay, so similarly NLP. So that is the thing. So I think I have crossed the time limit that I have been given. So let me stop here. But I have created so many other slides. Okay, what is the difference between cloud AI and edge AI? Okay, edge AI, human pose estimation, real-time human pose estimation by edge AI, human being modeling using artificial intelligence. It's go on for another 10 slides. Okay, I stop here. If anybody wants this slide, I think I can share it with Rahul or event organizers. I can share the slide with them. You can get it from them. Okay, so if you have any questions, you can type it in the chat window. I and Rahul can answer those questions. If there are no questions, or you can send out an email to me as well as Rahul. We will answer your questions leisurely through our email things. Otherwise, I want to end this session with what I can say with the joke. Okay. So in long running session, I used to end every session with a joke. I might have told this joke hundreds of times. Okay, so the joke is nothing else. Einstein, correct? He is the inventor of not inventor, discoverer of what is that? I forgot that gravity thing, correct? So this Einstein is from UK, I think so, if I'm not wrong. He goes to several colleges and universities to give a talk. Okay, this happened several years back. Once after so this he goes in a jeep. The jeep driver also attends all the session. Okay, so the jeep driver also attends the session given by Einstein. So after 2 or 3 years, this Einstein is going to Oxford University to give a lecture. So on the way, the jeep driver told Einstein, "Sir, this time I will give the lecture. You sit in the last row of the auditorium." Okay. So Einstein accepted that. So in the car, in the jeep, Einstein gave his address to the driver. Driver gave his address to Einstein. So now they entered into the auditorium. This Einstein, real Einstein, is sitting in the last row. The fake or the virtual Einstein is giving the lecture. He gave a very nice lecture. Okay, because of his learning, he got it from Einstein for the last 2 or 3 years. So he gave a very nice lecture. People are so excited about the lecture. So now the question answer session started. So many questions were put forward in front of him. This driver, this jeep driver, was giving giving all the correct answers for all the questions given to him. Finally, there was a very last question. This question was really tough. Okay, really tough. But the jeep driver found it very difficult to answer this question. He found it very difficult, but he is very smart guy. Okay, he told the audience, "This question is very simple and silly question. I do not degrade myself by answering for such a question. What I will do, I will call upon my jeep driver to come to the stadium to answer the question." That is the end of my session. Thank you so much for your listening. If you have any questions, you can shoot up or you can send out an email. Thank you so much for listening to our lecture. Rahul, if you want to say something to the audience, you are go ahead. Thank you so much for all the people, not only for the organizers, but also for the participants.
Thanks, Mr. Pathu. Today, I will summarize the webinar on AR, VR, and Metaverse. As has been told by Rahul, that in 1968, this technology got developed, and by Evan Sutherland, who is the father of graphics. Now, the virtual reality has been narrated as an artificial rendering of an environment, making use of audio and visual fields, possibly supplemented with other sensory devices. And it has been told that to support it on the handsets, you will be using the thin client, which will be able to give it a faster resolution and a faster working. There will be a huge application of virtual reality in training, environment, retail, health sectors, etc. Now, it has been also been told that as a very native thing that the virtual health worker named Florence is used by WHO for a campaign to quit tobacco. Now, the augmented reality is just the reverse one of virtual reality, which is a presentation method where objects in the real world are supplemented with artificial objects, which can be either constructive or can be destructive. And the example was the Pokemon Go game, which was released in 2016, which is an example of augmented reality in constructive way. Now, for this thing, 5G is playing a great role over here. The technology for up to 4G was not suitable to handle this augmented reality and virtual reality, primarily due to the latency. Now, here, what will happen, this streaming of 360-degree video will be requiring a huge bandwidth. And not only the bandwidth, the switch of application should be there within around 10 milliseconds. And it will be requiring a latency of this order, and there will be a frame rate of 120 frame rate per second, and the data rate will be of the order of 500 to 700 megabit per second. So if you want to go with this type of environment, so you require basically some kind of, the ecosystem. The ecosystem will be in terms of the connectivity, components, devices, and the devices is having a huge role play, like the VR head-mounted displays, AR glasses, 360-degree cameras. So these are getting also been enabled on the mobile phones. Network slicing plays a huge role, and jitter and the edge AI. So edge AI plays a huge role, which has been already been narrated by Mr. Petro in a detailed manner. And we have seen the digital implication are the millions of the microservices, billions of connected and cognitive devices, trillions of digitized entities. It has been already been told that about 2 trillion devices will be there by 2025, and 1 million devices per square kilometer is the network capability or the network density in 5G environment, and the zettabyte of the digital data. We have seen that Web 3.0, which is leading for the Metaverse, is having the features of the decentralized, blockchain-based, cryptocurrency enabled, and autonomous and AI enabled. Digital twin plays a huge role in Metaverse environment. A digital twin is basically an exact virtual representation of a physical object in the digital world. Basically, it takes a real-time object, real-life object, and creates an exact copy of that same object in the digital world. Nowadays, it is coupled up with the different kind of analytics, specifically known as the D2, P2 analytics, descriptive, diagnostic, predictive, and procrastinative. So this type of prescriptive analytics, so this kind of analytics in the industry 4.0 is having huge applications like the predictive maintenance. Before any system goes down, it will be predicting the which particular component is going to become faulty. So this is going to have a huge implications, and it is having the different kind of applications like Metaverse for shopping, entertainment, can be utilized for the tourism, and already been it has been told in a very narrative manner, like virtual fitting room, which will be coming in the Amazon and everywhere else. Now the big picture comes with the enterprise space, cloud space, and embedded space, which will be integrated over an integration bus. So this is the basic picture which has been narrated, which is going to come in a big way. 5G is going to become a completely a trendsetter for this particular environment. I was physically available in India Mobile Congress this year, where all these technologies have been shown over there, and I personally experienced all such AR/VR environments and physically with the different type of gears. So with these things, I want to conclude over here, and now we'll be going to the question answer session. There are the several questions have been asked, and already several questions have already been answered. One question came by Mr. KVB Prasad: in what way we can use AI in the police department? And similarly, same question, similar kind of question, one thing comes specifically in crime analytics. Mr. Pethuru, can you?
Yeah. So,
Please.
yeah, AI is the future technology. Okay. So AI will be leveraged across industry verticals. Here, as I understand, the question is for police department or crime control, correct? How AI can be leveraged. So one interesting example is several years back, some people from Israel wanted to go to Spain for a vacation. So now one guy was wandering inside the Spain airport. So all his images were captured by the CCTV camera that are there in the airport. All the images captured by the CCTV camera were sent to control room. So all these things. But now the Israel people arrived at Spain airport. They came out of that airport. They entered into the bus. This guy was wandering inside the airport. Went in front of that bus. He committed suicide and he killed all the 20 Israelites in that bus. Okay. What I'm trying to tell is, all the data that are being captured by CCTV cameras can be analyzed locally in the camera itself. Otherwise, all the images of that person who is wandering inside the airport could be analyzed by cloud-based data analytics platform, so that based on the behavior of that person inside the airport, the analytic solution or the AI solution would have informed the airport police that something wrong with that person, please catch hold of him. Okay, please interrogate him, something like that, proactively, preemptively, so that that nonsense could have been avoided. So why I am telling this, AI plays a very important role locally as well as in cloud level. Okay, you can send the data to faraway cloud, or you can send the data to local cloud inside that airport itself, so that you could have avoided that crime committed by that person. Okay, so now a variety of CCTV cameras that are capturing the images, that images are being stored in a centralized place, that is called historical data, and real-time data is also getting captured by the camera. So through AI-based machine learning algorithm, the RDL algorithm, it is possible that whether there is any wrong person who have entered into that particular crowded place or not, so that the police can take action immediately before something bad happens. Okay, so all kinds of data about the people who already involved in rowdyism or in illegal activities or indecent activities can be captured, stored in a centralized place. So when you apply real-time data plus historical data to AI, because AI needs a lot of data to arrive at very accurate prediction. Okay, so AI plays a very important role. Data is the primary ingredient for AI application or AI model to come out with the accurate prediction. Okay, so that is what I could think of, especially on AI. So today, a lot of data are getting collected, but they are not processed properly. Okay, that is the lacuna, that is the gap. So when we have AI systems in our everyday systems, this data crunching will go up. Today, unfortunately, out of the gathered data, only 1% of the data are subjected to AI investigations. But when AI systems very plentiful, available everywhere, that the data can be, all the data can be crunched, so that it can throw a lot of actionable insights for people to take countermeasures immediately. So
Okay.
that's what I could tell.
Okay, thanks. Next question by Mr. Aniruddha Prasad Yadav. His question is what was the difference between internet and cloud and fog? So this thing has already been explained in the class today in the later portion, and the complete narratives have been given. And this typical application will be found in the automated car driving and several other aspects which has already been narrated by him. Mr. Ashok Kumar Panda, he has asked for any light on electromagnetic pollution aspects and implications.
What is that?
Electromagnetic pollution aspects and implications.
Okay, so pollution, how this metaverse comes into picture, I do not know.
Anyway, I will answer to this. I will answer to this question.
Okay, thank you.
In any country, all other countries, if you see the lowest frequency is F. So F by 200 is the so much watt per square meter is the basically limit for the, whenever you are radiating, this much power you can send in any direction. So what happens is, in a country like India, what has happened is that further it has been reduced by 1/10. So it must be F by 2000 watt per square meter. For example, if you are having radiation at the range of, say, so far, say 700 megahertz band, and 700 megahertz is the lowest band if you are utilizing. So it will be basically 350 milliwatt per square meter. So you cannot radiate more than that. All operators are to cooperate on these things, and DOT is having a special cell, that is the term cell. So what they do is that they are having a specific measurement equipment, which they measure it when with the antenna and that is a portable antenna and the spectrum analyzer, where they collect how much is the radiation collected from the all other antennas collectively, and it should not be more than 350 milliwatt per square meter in any direction. So they measure it all the places, and it has been found all operators are cooperating to these things, and everywhere, whenever operators are putting on the tower and others, there it is on pledge has been written, and that it is written that it is an electromagnetic radiation environment near to that. So caution template has been provided, and if it is not provided, DOT is imposing huge penalty on the erring operators. Even they have to conform to this standard, and DOT periodically checks continuously every month basis the sites, and everybody has to conform to these things. So this electromagnetic pollution, whatever might be radiation standards, are kept in these things, and it is conforming to the WHO standard, right? So another question which has come is, thank you, sir, for delivering so nice and informative session. Shall expect in future for such different sessions. Thank you very much for your comment, Mr. Amit Chandra. And definitely this encourages us to prepare the next high level of presentations month by month. And every month we are doing this. Mr. KVB Prasad has told for plotting locations of the suspected targets, currently it is required in plotting. So I think our Mr. Pethuraj has already, he has explained it, that how the targets can be the suspected and along with the locations. Another question came from him. Yes, sir, CCTV is very much useful for analysis.
Yeah. So yeah, CCTV cameras are nowadays attached with this analytics software, that is AI software. Okay, so it capture the images and it capture the videos also. Immediately inside that CCTV camera, that data processing starts. And once the data processing starts, it will come to some certain inferences, some conclusions, some predictions. That insights will be passed on to the concerned person to take countermeasures. Okay, so it is getting implemented nowadays. Okay, so we have been using CCTV cameras for a long time, but nowadays the latest, I was going through a drone paper. Therein they have clearly articulated the drones are equipped with a CCTV camera with the GI software. So drones can understand what is the image, what is it's all about representing, what actions can be taken based on the image input, visual input, video input. Okay, so that is happening. So we will hear more about that maybe in the years to come. So we will be little slow compared to other countries in embracing newer technologies. So it will take some time. Okay, so definitely we'll hear about that. So CCTV cameras are being incorporated, being embedded with a variety of analytics software. Okay.
One question came from the anonymous attendee. Is sir, can you please explain?
Sorry to interrupt, sir.
Yeah.
Sir, we have another webinar scheduled
Yeah,
soon after
this is the last question. This is the last question we are taking.
Thank you, sir.
Can you please explain the implications of unreplicable wave in the metaverse?
Honorable?
Unreplicable wave in metaverse.
I couldn't, please repeat the question.
The question is, please explain the unreplicable wave in the metaverse. Unreplicable wave in the metaverse.
Okay, so yeah, so I couldn't understand. So if
Anyway,
possible,
what we can do is that, Mr. Raj, because of the
I can
constraint of
send out
time,
a
what you
mail.
can do, you can we can write us back so that we will be writing to them, right?
Yeah.
Yeah. So thanks a lot, everyone. And now we'll be asking Dr. Raju Basak to give vote of thanks.
Thank you, sir. Is it audible?
Yeah, you are audible.
Thank you very much for giving me the opportunity for the vote of thanks. So it is my proud privilege to extend my sincere thanks and gratitude to all the distinguished participants in this technical webinar on the theme AR and Metaverse. Organized by the Electronics Engineering, Electronics and Information Technology Demonstration Center IEI through this online platform. So at the outset, I want to give sincere thanks to the panelists, Mr. Petruraj, Chief Architect and Vice President of PH, AI Division, Reliance Jio Platform Limited, Sheffield, and Mr. Rahul Kumar. My sincere thanks also goes to the people last year at the Demonstration Center, IEI, Dr. H.O. Dr. President IEI, Mr. Sandeep Kumar, and Vice President IEI, Mr. Professor Dr. Verification for the Chair, Division Board IEI, Dr. G. Raghunathan, RTIEI, Mr. Dr. Murthy, Convener, to the same feeling also goes to the all members of the council and the division board members of ETDV and all members of the committee of West Bengal State Center IEI and all members of ET Engineering Divisional Subcommittee, the Director Technical IEI and his team for their wholehearted support to make the program success. Last but not the least, my sincere thanks also goes to the all the persons, those who are behind the scene and giving their silent support to make the program a success. Thank you all. With this, we are concluding today's webinar here. Thank you very much.
Thank you very much.
Thank you.
Look forward to meet you in the next session in the month of December.
Yeah. Thanks, Mr. Prithviraj Raj and Mr. Rahul Kumar for giving scintillating presentation today. And so much involvement, so much questions also came. People wanted to know. So thanks for everyone's patience and have a good day. Thank you very much.
Sir, it was really honor for us to invite in this prestigious session in front of such distinguished people. Really, it encouraged us to participate in the more aggressive way in coming days. Thank you so much. Thank you.
Thanks.
Sudeep, we can close now.
Thank you, sir. So I am ending the webinar.
Yeah, please.
Thank you so much for your kind help and support.
Thank you, sir.
Thanks.